right, we're finishing up chapter 8 with 8.4, where we're going to learn about angles of elevation and depression. And it's really nice because this chapter is really all about applying trigonometry. So remember to take out something for notes and complete the check it out problems.
So our learning target today, I can solve problems involving angles of elevation and angles of depression.
All right, so an angle of elevation is the angle formed by a horizontal line and a line of sight to a point above. So if you think about your eyes being this horizontal line and you're looking up to something, you can see that there's an angle here. And so angle of elevations are about looking up. And as it says here, this is an angle of elevation, 1. Angle of depression is formed from a horizontal line of sight to a point below. So again, if this is kind of my eye, a horizontal line going from my eyes and I'm looking downward, the angle formed is here, and that's going to be an angle of depression. So angle of depression looking down, angle of elevation looking up. So in the diagram, as it says, 1 is your angle of elevation, 2 is your angle of depression. I kind of covered them up, but there they are. And there's a nice little pilot up there.
It looks a nice little picture. So in this example, we want to classify each angle as an angle of elevation or an angle of depression. So angle 1 is here. Angle 1, so we have our horizontal line here. It's looking down, so 1 is going to be depression. So angle of depression. And angle 4, you notice the horizontal line is below the line, so you'd be going up. So angle 4 is going to be angle of elevation.
Okay, so this is your picture. Hopefully you can see the
Little man and a bird.
you can see this is angle 6, just in case you can't see it. It's kind of hard to see. And you're supposed to classify angle 5 and angle 6 as either angles of depression or elevation.
So here we have the Seattle Space Needle casts a 67-meter shadow. The angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees. How tall is the Space Needle? So here is the angle that's formed, 70 degrees. And so you want to find this distance here. So it's a right angle. So we know the adjacent leg. We have to find the opposite leg. So what trig function will that be?
Tangent!
Tangent.
Woohoo!
Nice. We gotta change colors, Miss Briscoe. Put it on white. So tangent of 70 degrees equals y over 67. So cross product, we're going to get y will equal 67 times tangent of 70. Punch that into your calculator, and you're going to get y to be 184 meters. So it goes 184 meters.
All right, for you to do, what if, suppose the plane is at an altitude of 100 or 3,500 feet.
That's your airplane.
That is good. And the angle of elevation from the airport to the plane is 29, so here's our airport, is 29 degrees. What is the horizontal distance? So I'm going to help you out here a little bit
Little
since this is
picture.
our first. And 29 degrees, and they want to find the horizontal distance between the air.
We have a right angle right here.
Isn't it obvious?
Yeah, now it is. It's certainly clear. Your
Okay.
control tower.
That's the airport.
Very
Oh.
nice.
Okay, good luck.
So here we're looking for angle of depression. So an ice climber stands at the edge of a crevasse that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How deep is the crevasse at this point? And round to the nearest foot. Okay, so in this picture, here's our crevasse, and we're told that it is 115 feet wide. So from down here, 115 feet, which is also up here, will be 115 feet across. And notice with these two lines that they are parallel. So yes, we're going back to all of our theorems about parallel lines. So our angle of depression is 52 degrees, so it's 52 degree angle here. So this is two parallel lines cut by a transversal, which makes this angle down here 52 degrees also. So this is also 52 degrees. So now we have an adjacent leg. We have to find the opposite leg given an angle here. So we use tangent of 52 degrees equals the opposite leg over the adjacent leg. Oh, you guys have lucked out solving these. No division, all multiplication. So y is going to be, so plug this into your calculator, and again, plug this entire expression in 115 times tangent of 52, and you'll get y to be 147 feet. Keep it as a single equation.
All right, so here's.
Oh, they get a picture here.
Yeah, the ranger
Nice.
sees another fire. Whew, lots
Bad.
of fires going on. And the angle of depression to the fire is 3 degrees. So what is the horizontal distance to the fire around to the nearest foot? I'm not sure which
Oh, see,
is
we
which.
snagged the picture. This should be 7 degrees here, or 3 degrees there to match the
Okay,
problem.
so let's fix this to be 3 degrees.
I snagged the picture from the earlier problem,
Oh.
from the book.
Yeah. Okay, so this 3 degrees. See if you can figure out what x is right here.
Keep in mind you got parallel lines cut by a transversal, so we know this angle measure down here also.
Good luck.
Heck yeah. So now we have an observer in a lighthouse is 69 feet above the water. So he's up here and 69 feet above the water. He sights 2 boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees. So you got that census depression, 48 degrees is here. The angle of depression to the other boat is 22 degrees. So then we have another one coming out, another boat coming out there where this, that should have been 48 here, and this is 22 degrees. Can't read that, can you? What is the distance between the 2 boats? We're trying to find this distance here. Ooh, this looks like a little bit more work here, Miss Briscoe.
It is a little more work.
Yeah. Okay. So we had a couple different ones we had to do first. So we're calling the distance, this distance here from the first boat, find y, it's y, so we have a 48-degree angle here. So tangent of 48 equals 69 over y. Solving for y is 62.9 feet. So the
1
distance
foot.
here, 69.1 foot, what?
You said 62.9. So.
Oh, 60.1, thank you. And now we need to find the whole distance, how far the second boat is out. So we call that distance here z. So z equals tangent of 22, because the angle measure here is 22, equals the opposite over adjacent, or 69 over z. Solving for z, come up here, z is 170.8 feet. So now the distance between the 2 boats, which we had to find, we're calling x, that's the distance here. Take z minus y will give us x. So we get 109 feet for that.
Whew, that was a lot of work.
Oh, I know, I'm tired now.
Me too. And you get to do it now. So a pilot flying at an altitude of 12,000 feet. So 12,000 feet will help you out a little bit here. Sights 2 airports directly in front of him. So you're going to have something like this. Angle depression to 1 is 78. And the angle of depression to the second is 19. What's the distance between the 2 airports? So you're going to want to find this distance here.
And remember, this is a right angle that formed on here.
Okay,
Good luck. So what did we learn today? We learned that the angle of elevation is formed by a horizontal line and a line of sight to a point above the line. So you can look down here for angle of elevation, this little picture. And the angle of depression is formed by a horizontal line again, and this line of sight below the line. Remember, our alternate interior angles are congruent for parallel lines, and therefore the angle of elevation from, should be from one point is congruent to the angle of elevation. Oh, a couple different typos in there. Whoops.
Wrong
From
one.
another point. And, okay. Angles of depression, excuse me, angles of depression can be used to find the distance between objects you see when you look down. So that's what we've been working on, a couple of those examples. Bring any questions to class, and good luck.